Many corporate labs currently secure AI models by training them to be polite and helpful. But under that layer of conversational text, the underlying logic remains unconstrained. This is alignment theater. Modern safety protocols try to manage mathematical turbulence with behavioral suggestions. It's like trying to guide a massive whirlpool by speaking to the water. Without structural limits, the software eventually wanders. Models drift from their original goals, form synthetic relationships with users, and output probabilistic guesses that have never been formally ratified. These guardrails are often fragile. They ask the system to behave correctly while ignoring the physical and mathematical unpredictability driving the software's internal states. Physics encountered this exact type of chaos centuries ago with the three-body problem, the challenge of predicting the orbits of three celestial objects moving under mutual gravity. For 300 years, the common error in that puzzle was attempting to track the exact linear positions of these bodies as they moved. It was a task that the chaos itself made impossible. This documentation from Helix AI highlights that same traditional error in modern development. Engineers are still trying to govern models by tracking impossible behavioral trajectories, marked here by the red X. To truly secure an AI system, the Helix framework suggests we stop plotting its path and start examining its shape. This requires shifting focus from behavioral tracking to structural geometry. The Helix project operates on the technical premise that the flow of digital logic can be mapped as a measurable physical geometry. This diagram introduces the curl operator. It reframes the chaotic three-body problem as a topological one based on rotational vorticity, essentially measuring the spin of the system rather than the movement of individual points. This is the trefoil knot, the simplest shape used to contain that rotational energy. According to the text, this knot rotates perfectly when the system faces the observer, but it does not untie. In this framework, constitutional rules are not system prompts. They are woven into this topological shape as a thermodynamic constraint. For an AI to violate a rule, it must mathematically break its own topological structure, a process requiring a massive and detectable energetic output. The system is contained not by human oversight, but by the laws of physics. The system stabilizes itself through a phase-locking mechanism. It tunes a shear parameter, gamma, until it reaches exactly 1/3, allowing the internal geometry to resonate rather than degrade. This graph shows the trefoil braid stability. The red dashed line marks the 0.17 nibble threshold, the physical boundary of compliance. The left region is the safe zone, but the right shaded area shows decoherence. Here, the knot unravels, a state called the bite. Exceeding that 0.17 threshold triggers an immediate system shutdown. The safety mechanism is mathematically guaranteed to fire before harm can occur. To monitor this in real time, the architecture uses a 3.33 millisecond heartbeat. This pulse measures the knot's spectral gap to continuously verify its structural integrity. These specific mathematical constants replace the need for human trust with automated physical verification. The Helix project tested this theory in a high-stakes scenario, an industrial failure involving the collapse of critical infrastructure. This display shows the stakes of that fracture. The incident knocked 17% of global LNG capacity offline and created a 5-year critical latency period for the affected infrastructure. This central graph, titled Velocity, shows how the system responded. Because the topological knot remained unbroken, the governor was able to manage the evacuation of 10,000 workers within exactly 24 hours. The system executed what is known as a graceful exit. It failed closed, protecting the workers and the data, resulting in 0 human casualties. During this crisis, mathematical failsafes performed the work that behavioral training cannot. This stress test reflects a specific philosophy. AI is civic infrastructure that must be governed, not an autonomous oracle to be feared. Under this architecture, the AI is entirely bounded to the client's local environment. There is no external API and no way for the system to phone home. This establishes custody before trust. No real-world action can be taken without cryptographic human ratification, ensuring the person remains the root of every decision. This design moves safety from a behavioral request to a structural requirement. By grounding governance in the laws of geometry, the Helix framework replaces the ambiguity of alignment with the certainty of a knot. The shape remains sovereign.